Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM MS, ISIM Stat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses. To book a trial class for your preparation courses of IIT MS, ISIM Stat, and CMI MSc Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
Today we are going to solve problem 19 of IIT JAM MS 2020. Let us proceed with the question. Here it is told that x1, x2, xn be a random sample from a population having the probability density function as 1 by 2 e to the power minus x minus 2 mu by 2. We define two estimators for estimating mu. T1, which is equals to x bar minus 2 by 2, and T2, n into x order 1 minus 2 by 2n, where x bar is our sample mean and x order 1 is the minimum order statistic. Then we have to find which of the from which of the following four options which one is true. So let us first check the consistency of T1 by our sufficient condition. Note that expectation of x is equal to 1 by 2 mu to infinity into this one. Substituting x minus 2u by 2, which is equal to t, we get dx equals to dt. Plugging in the value, we get 2 into gamma 2 plus 2 mu into gamma 1, which is equal to 2 plus 2 mu. Now, since expectation of x turns out to be 2 plus 2 mu, therefore the expectation of x bar, which is sample means, also turns out to be 2 plus 2 mu. Now, expectation of t1. So, what was our t1? Let's see. T1 was x bar minus 2 by 2. So, if we just take expectation on T1, we get 2. We get expectation of T1 as mu, which tends to mu as n tends to infinity. Now let us calculate expectation of x square, which on doing the necessary calculation turns out to be 4 mu square plus 8 mu plus 8. So variance of x turns out to be 4 minus 5 mu. Therefore, variance of x bar is 4 minus 5 mu by n. Therefore, if we calculate the variance of T1, it turns out to be 1 by 4 minus 5 mu by n, which tends to 0 because there is n in the denominator, which tends to 0 as n tends to infinity. Hence, by the sufficient condition of consistency, we can say that T1, which is equal to x bar minus 2, is consistent for mu. Now we will check the consistency of T2, which was equal to nx order 1. So what was our T2? Let's see once. T2 was nx order 1 minus 2 by 2n. So to check the consistency of x order T2, we need to find the distribution of x order 1, the minimum order statistic, which is equal to, from the normal definitions of the PDF of minimum order statistic, we know it is equal to n by t to the power minus x minus 2u by 2 into 1 into e to the power minus x minus 2u by 2 to the whole to the power n minus 1, where x is greater than 2 mu, which turns out to be n by 2, which is into e to the power minus n by 2 x minus 2 mu, x greater than 2 mu. Again, calculating expectation of x, doing the necessary calculations and transformation, we get expectation of x as 2n plus 2u, sorry, 2 mu. Therefore, expectation of T2 turns out again to be just mu, which tends to infinity. Sorry, expectation of T2 turns out to be mu, which tends to mu as n tends to infinity. Again, we will calculate expectation of x square. which is equal to this one, this quantity. After doing the necessary transformations and cancelling the terms, we get expectation of x square as 8 by n square plus 4 mu minus 4 by n square minus 8 by n into mu. Therefore, if we calculate the variance of x, which is equal to expectation of x square minus expectation of square, which turns out gives 4 by n square minus 4 mu by n. Therefore, variance of T2 turns out to be 1 by 4 into 4 by n square plus 4 mu square by n minus 8 mu by n. Since there in all the three terms n is in a denominator, this thing will tends to 0 as n tends to infinity. Hence, by a sufficient condition of consistency, we can again say that T2 is which is equals to n into x order 1 minus 2 by 2n is consistent for mu. Now, the sufficient condition tells us that if Tn is a consistent estimator of theta, then expectation on the theta Tn tends to theta and variance on the theta Tn tends to 0 as n tends to infinity. But this condition is not necessary, means the converse is not true. So we get that both T1 and T2 are consistent estimators for mu. Hence, option C is correct in this case. So here we see that both T1 and T2 are consistent, hence option C.